All right. Good evening, everybody. Sorry about that. Hold on a moment. Get this volume down. Okay. Now I can't hear myself, which is good. All right. Good evening, everyone. This is going, well, there's one person here now, but for anyone who will be following along later, this is the study session for test number one. Again, when I looked at the time for this seemed to be the best time. So let's start off by taking any questions. Good evening. Let's start off with taking questions. I have the hopefully you don't hear all the clicking going on, but I have all of um, the study guide pulled up. So if you had any questions about it, I'd like to take your questions first before I start. Just kind of going over questions. Are there any that you have? So if you hear background noise, that is Mrs. Davenport and Davenport Jr. making noise. All right, we'll be able to make a note card with Open Note. Yes, the email that I sent to follow this up will say that, but yes, you can use one sheet of notebook size printed paper, notebook or printer paper. And you can put whatever you want on it. And per the it mentions it in the syllabus, but I'll mention it now that when you start the test, with the environment check, you show your piece of paper front and back along with that when you're getting started. Well, you're welcome. Okay. Well, I guess I'll just start doing problems, and y'all can stop me when y'all have. Oh, wait a minute, it's not on. That's what it is. So you got a new. Whoops! No, don't do that. Got a new pen here, so I'm trying to get it figured out. All right. I think we're good. I'm gonna go ahead and just start with a problem, and jump in as you let me know your problem. So for the first problem that I have here, f of x, okay, is equal to. Can you see that? Kinda. Is equal to square root of 6x plus 18, and they want us to find the domain. All right. I will say my handwriting is not normally this bad, but well, actually, it's not on pencil and paper. On a board, on this, it's a little different. But anywho, all right. So we know that square root of x in square root of x has to be greater than or equal to 0. We cannot take the square root of negative numbers in this context. So we know that, therefore, 6x plus 18 has to be greater than or equal to 0. So subtract 18 from both sides. This is basic equation solving. Greater than or equal to negative 18 over 6. That means x is greater than or equal to negative 3. This is inequality notation. Interval notation means, and they ask for interval notation. That means that the less than or equal to means we have a bracket. We have negative 3 as a minimum value, and there is no maximum value. It just keeps going, so infinity. Boom. And that is the answer to that one. All right. Again, feel free to jump in with questions. All right, next problem. To save space, I will do it over here. And they have u squared. Yep, you can see that u squared plus 8u plus 16. And we want to solve for u. So solving that, we want to know what of u equals 0. Probably should erase that. We want to know what of u makes this equation true. So, oops, back to blue. To factor this, there are a few different ways, but because the leading coefficient is 0, and both of these are pluses, that means that my two factors, u and u, plus and plus, because there's no leading coefficient and because both of these are pluses. And we ask what two numbers multiply to 16 but add to 8. And we know that that is 4. So that means that, u is equal to negative 4. Oh, well, I'm skipping a step. And apparently making a big mess here. All right, so that means that u plus 4 is equal to 0. Subtract 4 from both sides. It means that u is equal to negative 4. And that's your only answer. Mm-hmm. And again, my intention is not to go through all 60 questions of the study guide, but you have the answers. If there any that you need me to work out, that's kind of what I'm looking for. Factor completely. 36 minus 4x squared. All right, so one of the things we know, I'm sorry, I'm trying to deal with some of this volume. This is 36 is 6 squared, and 4x is 2x squared. So this is a difference of squares. All right, in the difference of squares, there's a formula that we have for that. Red is what I write my formulas in, or properties. A squared minus b squared factors into a plus b, a minus b. So this factors into 6 plus 2x, 6 minus 2x. But they did ask us to factor this completely. All right. And we know that in the first two terms, and I could have factored this up front, and I probably should have done that. But I don't want to go backwards. So this one both of these are divisible by 2. So this is 2 times 3 plus x. And this is also 2 times 3 minus x. And the 2's go together. So this is 4 times 3 plus x, 3 minus x. And that is my final answer. Mm-hmm. Okay, this problem. Oh gosh. Um, I'll just read it because I don't want to show you my messy desk, and because it doesn't go, it isn't early. It's like interpret the domain and range of a problem. So the owners of a recreation area filled a small pond with water in 120 minutes. The pool had some water at the beginning. The graph shows the amount of water in liters in the pond versus time in minutes. So time is my x-axis. I'll sketch it. Y. That's x. We start at 300. All right, and we go to up to 750. That's 750. The time is 120. Okay, and again, it's more elaborate than this, but it's this is just a sketch. And they ask, find the range and domain of the function below. Well, we have enough information to do that. So for my domain, that is all possible x values. So that is inclusive 0 to 120. Because it's a value at both of those. And my range is 0. Well, actually not 0, because we didn't start at 0. We didn't start at 0. We started at 300. This is potential y values. So 300, and the domain goes up to, well, the range goes up to 750. And that's the domain and range. All right. All right. So for number 6, we have a function defined, and we're going to find f of x plus 1. So f of x is equal to 6 over 5x squared minus 3x. Right, and we are finding. Sorry, I keep messing with these. I mess with these lines because I have this out as a PDF. I'm writing on a PDF of blank sheets so that I can send it to the people who want to have it. All right, so we want to know, this is f of x. We're asked to find f of x plus 1. All right, and then simplify as much as possible. No parentheses. So this is 6 over 5 times x plus 1 squared minus 3 x plus 1. So in this problem, and I'm going to move this 6 because I like the number in the middle. Basically, everywhere there's an x in the problem, I've substituted an x plus 1. Okay, so then we do a little simplification. So 5x plus 1 squared is x squared plus 2x plus 1 minus 3 times x plus 1. 6 is on the top. Y'all can see that well. All right, so then we're going to distribute this 5 to everything, and then this minus 3 to everything. So this is, and don't let this fraction bar bother you. It's just kind of there. 5x squared plus 10x plus 5. That's an x. Minus 3x minus 3. the 5x squared stays. 10x minus 3x is 7x. And 5 minus 3 is 2, positive 2. And that's our answer. Wow, it's 15 minutes already. Okay. 6. All right. Find the excluded values for the expression. Excluded values are values where your x value is undefined. So 2 over 3x minus 15. We're supposed to find the excluded values. All right, excluded values are only where the denominator equals 0. All right, so that means 3x plus 15, not 5. We're finding out where that equals 0. So, whoops, getting ahead of myself. Minus 15. 3x is equal to negative 15. Divide by 3. That means that x is equal to negative 5. Or rather, x is not equal to negative 5. Well, for your case, you'll just put x is equal to negative 5. But in real life, quote unquote real life, you would just put x is not equal to negative 5. And that's your excluded values. Sometimes there can be more than one. All right, again, we have an excluded value. We have an excluded values question again. We have, I should change colors. 7t plus 11 over t minus 6. Excluded values again. Again, that is denominator equals 0. T minus 6 equals 0. Add 6 to both sides. T is equal to 6. That's your excluded value. Okay. Let me just stop saying So the next question is actually 6 parts, but you're telling whether a graph is a function or not. Functions pass the vertical line test. Functions pass the vertical line test. The vertical line test is basically if you, well, not basically. The vertical line test is if you have a graph, and I'll sketch a couple of these. This is number 8. So, for example, one of the graphs looks like this. Like that. This is not a function. Because if I draw a vertical line through here, anywhere on the function, it meets the function at 2 different points. If it ever meets the function at 2 different points, it fails the vertical line test, and it is therefore not a function. So that's whether the function is like that, or right there, or if the function I have this type of function is called discrete. In other words, it's not continuous. It just has a bunch of little points. This function still There are two things that are right on top of each other. It meets in two places. So that's not a function. And this is not a function either. Any linear functions are functions. Parabolas, if they're up and down, generally are functions as well. All right, more of that. Again, your study guide should cover the same thing. Should cover the same things, but maybe in a different order. I know that it tends to do that, but maybe not. Who knows? 9 over square root of 2x. And they want to find 2 plus x. And they want us to find the domain of this. Okay. So for the domain, we know that the denominator can never equal 0. Cannot equal 0. It can be a negative number, but it cannot equal 0. So that means that root of 2 plus x cannot equal 0. But we also know that this number, well, that can equal 0. So that means that x is not equal to negative 2. We'll put a little cloud around that. But we also know that 2 plus x has to be greater than or equal to 0 because of the square root. So if we subtract 2 from both sides, again, we end up with x is greater than or equal to negative 2. Okay, we'll cloud around this guy too. But it can't equal negative 2, so that means that my domain is x is greater than negative 2. And that is my answer. So because I have two different domain restrictions, two different things that are two different things that are affecting my domain, I have to take the more restrictive of the two. All right. But in this case, the only overlap is this is greater than or equal to negative 2. This is not equal to negative 2. So in other words, if it can't equal negative 2, that means I can't include the negative 2. So it's just greater than negative 2. I hope that isn't too confusing. But it might be. But I hope it's not. All right. Let us continue. Wait a minute, I do 11. Yeah, I did. That wasn't. Apparently, I can't count. 7, 5, 4, 3, 2, 1. Okay. I don't know how I ended up. Oh, some of those graph ones I didn't do. I didn't do because you didn't draw a picture. Okay. More domain and range, but let's do it. And for us, this is number 10. So f of x, y'all can still see that, that's good, is equal to x over x squared plus 64. G of x is equal to x plus 9 over, understood, great, okay, good deal. X plus 9 over x squared minus 81. All right, and they want to know the domain of each of them. So, per usual, I will do it in different colors. So for this one, the domain, we know that cannot equal 0 on the bottom. So x squared plus 64 is not equal to 0. Actually, for our intents purposes, I'm not trying to get too theoretical on us. Let's just say equal 0. All right. Again, I don't want to get too far out there. X squared is equal to negative 64. Um, Again, for our intents and purposes for here, there is no domain restriction on here because a squared number can't equal a negative number. I mean, if we're doing negative numbers, we would say, you know, we would have I, but we're not. So no restriction. For this one, right? So it would be, so the domain would be, I should have changed those too fast. In domain, I mean, in interval notation, it'd be negative infinity to infinity. Some people like to do the, put it together. I like to do 2/8 just because it's a little more, in my mind, it's a little more symmetric. All right. For this one, the first thing that we always do is factor everything. So I have x plus 9 over x plus 9, x minus 9. This bottom is a difference of squares because the x squared is x squared, and the 81 is 9 squared. So this factors into that. If I need to talk more about that, definitely let me know. All right. So in this case, we see that we have two numbers and they cannot equal 0. So we'll say x plus 9 is equal to 0, and x minus 9 is equal to 0. All right. Subtract 9 from this, and we have x is equal to negative 9. Add 9 to this, and x is equal to positive 9. So these are my values. So we have negative infinity to negative 9, union negative 9 to positive 9, union 9 to infinity. That feels like a lot, but it's not. It's just saying at negative 9, which is here, and positive 9, which is there, the function can't equal either one of these values. Now, if you know anything about rational functions, you know that this 9, the positive 9, is a hole in the function, and this 9 is an asymptote. If you don't know what that is, then I don't know if you necessarily need to worry about it right now. Okay, sorry about that. Get this squared away. Yeah. All right. Let's keep going. I'm hoping that this is helpful, at least a little bit. Feedback is nice. If you have any particular questions, now would be good, or anytime would be good. I figure I've been going about 30 minutes now. I figure I'll go for another 15 to 30 minutes. It just kind of depends on demand. Like if this is helpful and people need help, then I can keep going. If it's not, then I can stop so you can enjoy your Labor Day. You let me know. Right, so f of x is equal to 2 minus 3x squared over x squared. I don't know why that did that. G of x is equal to negative 1 plus square root of 4. Negative 4 plus x, and h of x is equal to negative 4 times the quantity of negative 2 plus x. These are absolute value bars. All right, so they want to know f of negative 4 is equal to 2 times 2 minus 3 times negative 4 squared over negative 4 squared. 2 minus 3 times negative 4 squared is 16. Again, it's 16. 2 minus 3 times 16 is 48 over 16, which is negative 46 over 16. Divide both of these by 2, and I get negative 23 over 8. Now, if y'all are anything like my high school students, then fractions probably cause all types of fear and frustration. Have no doubt about that, or have no apprehension about that. I want you to notice what I did, which is basically I did the top, then I did the bottom, then I did the top, and I left the bottom, did the top, left the bottom, did the top, left the bottom. So although this is a fraction problem, I really kind of did it like two different problems. And then at the very end, I had to reduce it because both of these are even numbers. And then I reduced it. All right. So don't let fractions bother you, especially because in this class is going to be a lot of fractions. But that doesn't mean that it's doing a lot of fraction operation type things. All right. Let's keep continuing on. G of 7. G of 7 you could do negative 1 plus square root of negative 4 plus 7, which is negative 1 plus square root of negative 4 plus 7 is positive 3. And that square root belongs to 1. And there's nothing else we can do with that. All right. And then they want h of negative 2 is equal to negative 4 times negative 2 plus negative 2. These are absolute value bars. I mentioned that. They turn everything positive because they're a distance. Negative 4 times negative 2 plus negative 2 is negative 4, which is negative 4. If it helps, I can put a little multiplication symbol right there. Actually, I don't need a bar anymore. Negative 4 times 4, which is negative 60. All right. We like these types of functions because it's just plugging things in. All right. Okay, there's another domain and range function, but when you're looking at the graph, your domain is all possible x values. Your range is all possible y values. If you have a situation, if you have a situation where you have like a line or something, or it's more appropriately an array, which I guess I am doing this one. What number am I on? This is number 11, so this is the 12th one I'm doing. All right, so for this one, actually, it's not even like that. It's like maybe a real life problem. Most of the time, the graph is going to be in the first quadrant, which is where x and y are positive. And this goes like this because the person attached it to a line. Okay, if this point is 0, 0, which it is, then the domain in, let's see, your answers inequalities. So for your domain, x is greater than or equal to 0. For your range, y is greater than or equal to 0. This is inequality notation, where they're equal signs or not equal signs. Or unequal. Yeah, that. Unequal signs. Notation has parentheses. So this problem it's not very much to it. It's interpreting the graph. All right, another factoring problem. We like those. All right, I have 50v to the 4th minus 18v squared. The first thing you look for when you're factoring is, do all the terms have anything in common? These have a v squared in common because that's v squared. That's v to the fourth. And they also have a 2 in common. Right, so this will be 2v squared, and this is 25v squared minus 9. Right. 25 is a perfect square. So is 9. So is v squared. So remember that a squared minus b squared is equal to a plus b times a minus b. Right, so in this case, this is 2v times 5v plus 3, 5v minus 3. If you need to do the a squared, something squared minus something squared, we can do that. So let me put a box around that. Or you can say 2v times 5v squared minus 3 squared. And in this instance, this is your a value, that is your b value. And you just apply your formula here. Where's 2v? A plus b, 5v plus 3, a minus b, or a minus b, 5v minus 3. And that becomes your answer. To be honest with you, many times in my experience, many times students see problems and then they panic. They see, whoa. All right, don't know why that's popping up now. That's good. Sorry, just a moment. This phone is doing boom. All right. Taking off Wi-Fi too. So we shouldn't have any more interruptions. But you know how these things go. All right, so this is 14. F of x is equal to 2x squared minus 4. They want to find f of x plus 6. That means that everywhere there's an x, put an x plus 6. Two lines. This just means sub that into the formula, or sub that into the function. So this is 2x plus 6 squared is equal to, I don't know if I probably need to show you how to do that. I mean, I'm not trying to insult your intelligence or anything, but I don't want to leave anything out. Okay, so if I have different color, x plus 6 squared. This is, I make a box, x positive 6, x positive 6. This is the box method, or area model, way to multiply polynomials, in case you're looking for it. Box method or area models. So then x times x is x squared. 6x, x times 6 is 6x, and 6 times 6 is 36. And then you put it all together. X squared. In the middle, if you do them in order, then this goes together. These two go together. And 6x plus 6x is 12x plus 36. All right, so here we'll say x squared plus 12x plus 36 minus 4. This 2 on the outside goes to everything. That's called the distributive property. 2x squared plus 24x. That's not supposed to still be connected. Sorry about that. This thing is my phone is connected to my laptop, and I don't want it to be right now. Plus 72 minus 4. This is 2x squared plus 24x, and then 72 minus 4 is 68. Boom. All right. So, a lot of writing, a lot of work, not challenging though, as long as you take it step by step. Okay, this is more domain and range of a graph. We talked about that already. H of 7, we talked about that already. We are plugging numbers in and simplifying them. Factoring, we did. Domain and range again. Look at the graph and talk about symmetries. All right, equation of a line. I think we've done this before, but let's go ahead and discuss it anyway. This is problem number 15. All right, I'm going to find 2 points on the, there are a couple different ways to do this. All right, I'm going to find 2 points on the line. So 2 points are, I have -1, 1. And another point is 3, -5. -5. All right. There are a few different ways to do this. Normally, I would say you can find the x-intercept and find the slope. But this x-intercept isn't really clear. So we'll do something called point-slope form. This is red. Y minus y sub 1 is equal to m times x minus x sub 1. And we'll also use the slope formula. And actually, I wrote these in reverse. I should have done the slope, then that. But I'll number. So m is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Or we're going to say delta y over delta x. Now, I'm getting mathy here, but to explain, delta y means, delta means what's the difference of? What's the difference between two different values? So the difference between my y values over the difference between my x values. For both of these, you have to start at the same point. Okay, so we're going to start at our left-hand point and go to our right-hand point. I guess this would be easier with a graph, even though I think you know I'm trying to graph this. But a sketch, 1, -1 would be there. 3, -5 would be there. And this line, missed completely. Let's try again. Got it. Boom, boom. This is what it looks like. So you can find the slope by counting, starting here, and then going down to here, and then over to there. This is like rise over run, but it's an easier way to do it if you have a picture. But if you look at the points, you can see. So I feel like I'm doing too much, but let's just say that this is x of 1, this is y sub 1, this is x of 2, this is y sub 2. All right. From -1, we'll start with y's. If I start at +1 and I go to -5, so slope is equal. First step. If I start at 1 and I go to -5, I'm going down 6. If I start at -1 and I go to +3, then I'm going to the right 4. And then both of these are even, so I divide them by 2. And that is the slope. That's the quick and easy way how to find the slope. All right. So that's the first step. Second step, I use my point slope formula. I pick any point. I'm going to pick the first point because these numbers are smaller. Y minus y sub 1 is equal to m times x minus x sub 1. All of my x, m, x sub 1, y sub 1, you sub in, or you substitute. Y minus y sub 1 is 1 is equal to -3/2 times x minus -1. So that's x plus 1. Subtracting a negative yields a positive. So this is y minus 1 is equal to -3/2 x minus 3/2. I took the 3/2 and distributed it to both of them. I'm going to add 1 to both sides. But I can't add a fraction and a whole number without the denominator being the same. So 1 becomes, I don't know what that is. It's supposed to be an arrow, looks like a boot. Actually, take that too. All right, that's better. A little better. So 1 becomes 2 over 2. So -3 over 2. So y is equal to -3/2 x. -3 over 2 plus 2 over 2 is 1 over 2. So we're going to be minus 1/2. And that's my answer on my equation. Let me move this up so you can actually see it, not with the light reflecting off of it. All right, I'll figure the lights out. But that's how you solve a problem like that. Again, a lot of writing, but it's not a lot. Okay. All right, graphing the function is piecewise. You need to see that. If you have questions with that, let me know. Continuous means you can draw without picking your pencil up. 24. Graphing the function, you can do that. Graph the system, which is just graphing two functions. More graphing, transformations. Okay. Transformations. Okay. This is one that we can do. That was number 15, so this is number 16. Oh, you're still on the screen. What do you know? All right, I have 2 points. -5, -5, and 4, -2. And they want the equation of a line that goes through these 2 points. This is exactly what we just did. So 1, slope is equal to delta y over delta x. The change in y's. I go from -5 to -2, which is I'm adding 3. From -5 to +4, I'm adding 9. Both are divisible by 3. I divide by 3 and I get 1/3 is my slope. Second step. Y minus y sub 1 is equal to m times x minus x sub 1. All right, I'm going to pick the right hand problem because they're positive and smaller. But either point this will work with. I've actually tried it before. Y minus or y plus 2 is equal to 1/3 x minus 4. Y plus 2 is equal to 1/3 x minus 4/3. Subtract 2. 2 with a denominator of 3 is -6 over 2. I'm sorry, with a denominator of 3. is negative 6 over 3. Because 2 over 1, 2 times 3 is 3, 1 times 3 is 3. Well, 2 times 3, negative 2 times 3 is negative 6, and 1 times 3 is negative 3. We can talk about that more if you need to. Y is equal to 1/3 x. Negative 4/3 minus 6/3 is minus 10 over 3. Boom. All right, again, having fun, moving along. Transform each graph. That's just x values and y values, doing what they ask you to do with them. Okay. I'll do this over here because it's just a little explanation. 17. All right. An even function means it has line symmetry. Symmetry. That looks wrong. Over the y-axis. In other words, you can fold it in half. All right, you have to be able to fold it in half. This is shown by f of x is equal to f of negative x. In other words, if I have a function and I plug in a positive number into the function, or the negative of that, I put the negative of that positive number into a function, I get the same answer. Odd functions have rotational symmetry. About the origin. And that is f of negative x is equal to negative f of x. So in other words, if I plug in x and I get out a positive value, if I plug in negative x, it's like I get the negative of that value. That's my answer. All right, so graphically, that looks like y is equal to x squared. This is an even function, a parabola. It has line symmetry across the y-axis. This is an odd function. Y is equal to x cubed. You can put them in your graphing apparatuses if you want to. This has rotational symmetry about the origin. Those are the easiest examples of even functions and odd functions. And that's honestly, when I was learning it, that's what I use to help conceptualize it. Cool. Nope. Awesome. All right. Let's see what else we got here. By the way, I'm to number 30 in the study guide. So that's okay. Here we go. So that was number 17. It's number 18. We'll go for 5 more minutes. I haven't seen any questions. So we'll go. Whoops. There we go. We'll go for 5 more minutes. Unless anyone has any questions, we'll go ahead and ramp this down. Because my thought wasn't to talk for 6x minus 3y is equal to 14. And they want to know the x and y intercepts. To find the x-intercept means y is equal to 0. And then solve. 6x plus 3 times 0 is equal to 14. So that goes away. So that means 6x is equal to 14. Divided by 6. X is equal to 14 over 6, which is 7 over 3. All right, so your x-intercept is 7 over 3, 0. For your y-intercept, you guessed it, x is equal to 0. That should be a different color. 670 minus 3y is equal to 14. That goes away. So negative 3y is equal to 14 divided by negative 3. And I get y is equal to negative 14 over 3. So y-intercept is 0, negative 14 over 3. Boom. All right. If they ask for it, you can either put the point, or sometimes if they ask for just what is the x-intercept, then you could put 7 over 3. It just kind of depends on what the program wants, because Alex can be a bit finicky at times. I think that we would all agree with that. All right, final equation. Okay. This will be, if there are no questions, this will be the last problem. All right, so I have the line. This is number 19. Y is equal to 8x minus 5. So the first thing that is requested is we want to find a line perpendicular. Man, okay. This problem is going to be a little bit of work. So for part A, perpendicular in through 3, 6. So we're going to perpendicular to this, a line that's perpendicular to this line and passes through 3, 6. Okay, question I got, how many questions on the exam? Normally the exam is 20 to 25 questions. I think it's 20, but it might be 25. I think it's 25. Is there a time limit? Yes. I usually give you about between an hour 15 and an hour and a half. We'll say an hour and a half. We'll say an hour and a half. The most number of questions I'll ever have is 25. It normally ranges between 20 and 25 questions. Any more than that from in person, any more than that, people won't finish. So perpendicular means first step. Actually, that probably should be a circle. So the first step. If my original slope is equal to 8, then my perpendicular slope is equal to negative 1 over 8. All right. Whenever you take the perpendicular, then there you go with that. Okay. So it has a perpendicular slope. So they've given us a point to go through. So we just plug that into our point slope form. And I keep circling those things because in real life, I would circle them if we want to board. 2. Y minus y sub 1 is equal to m times x minus x of 1. So y minus 6 is equal to negative 1/8 times x minus 3. This is the point that they've given us. Because lines are infinite, they extend infinitely in both directions. And that means that as long as it's perpendicular to the line, it can hit the line at any point. So they just happen to want to go through this. So this is the point we use. So y minus 6 is equal to negative 1/8 x plus 3 over 8. Negative 1/8 times negative 3. Add 6. 6, if we need a denominator of 8, becomes 6 times 8 is 48 over 8. Yeah. All right, so y is equal to negative 1/8 x of, let's see, that's 51 over 8. And it's not even. So that is the answer to the first one. B, they want a parallel line in through 3, 6. All right, so parallel means that my parallel slope is equal to 8 because my original slope is equal to 8. All right, so that's the first step. Second step is the same as the other time. Y minus y sub 1 is equal to m times x minus x sub 1. Y minus 6 is equal to 8 times x minus 3. So y minus 6 is equal to 8x minus 24. Add 6. And y is equal to 8x minus 18. So I complained about this, but it actually wasn't very much work. This is more an interpretation problem. Namely, you interpreting, okay, what am I doing here? Where am I going? Right. But this is pretty straightforward. So, are there any questions? Are there any questions? I don't want to have a live of 2 hours. I want to make sure that I'm answering questions that are asked. And again, I've been doing all the talking for an hour. So, are there any other questions that we have? Excellent. Thank you so much. I am glad to have been able to help. If you have any other questions in your studying, I did not want to. I didn't want to have this right before the exam. I wanted to give you a couple of days, and I definitely didn't want to have it on Labor Day. If you have any questions, definitely feel free to email me those. Any emails that are outstanding, I'll get back to you. And this will conclude our session.